Hello students, in previous class we have seen two important things. First one is whenever you are moving along the direction of current through the resistor, there will be a potential drop. That potential drop amount is IR. So we will write minus IR because there is a drop in potential. And when you are moving in opposite direction of the current through the resistor, there will be increase in potential, that you write plus IR. I is your current and R is your resistance, that thing you know. Also we have seen that when there is a EMF, if I am moving from positive side to negative side, then there is a potential drop of E, or you can write the drop potential is minus E, right? So there will be a drop in potential, so due to drop you will write minus E. And whenever you are going from negative to positive, there will be increase in potential, that you will write plus E. Clear? This thing we have seen. Now depending on this concept, today we will do lots of problem and much more concept we will learn depending on this concept, right? Let's start today lecture. This is the fourth lecture of the current electricity. Okay, so first we will see Kirchhoff's current law, that is called KCL. Kirchhoff's current law, or this is a KCL, the short name. This law is basically derived from this conservation of charge, right? This law is derived from conservation of charge. What this law is actually saying here, the total current entering a circuit junction is exactly equal to the total current leaving the same junction. You just, I know you couldn't understand anything, just I will draw something, then it will be easy for you to understand. So let's say this is a junction, and from this junction, this is I1 current is going out, I2 current is going out, I3 current is coming in, and I4 current is coming in, and this is a junction. So you will say that total current entering a circuit. So how much current is entering here? You will say that I4 plus I3. So I will write total current entering. How much it will be? You will say that entering will be I3 plus I4. Then total current leaving. Total current leaving through this junction will be how much? We will say that I1 plus I2, right? So through this law you can say that total current entering is equal to total current leaving. So you can say that I3 plus I4 is basically equal to I1 plus I2, right? I1 plus I2 total current leaving, I3 plus I4 total current entering. Clear? So I can write this law in another way. So what I will basically write, I can write I1 plus I2 minus I3 minus I4 is equal to 0. What it is basically saying? You see, this is the junction here. I1 and I2 current is moving out, right, or leaving this junction. I4 and I3 is entering to the junction. The current is entering to the junction. So if I write minus I4 and minus I3, you can say that I4 and I3 minus I4 and minus I3 actually leaving this junction, because plus I4 is entering, I can say that my minus I4 is leaving, so that thing I am leaving, right? So I can say that summation of I out is equal to 0. I can write. You understood, right, what I am saying? I3 is entering here, right? I3 current is entering here, or I can say that minus I3 is leaving, so that thing I am telling. So this one you can write like this also. You can say that I1 plus I2 plus minus of I3 plus minus of I4 is equal to 0. I will say that minus I3 current is basically leaving this surface. I3 is entering to the surface, minus I3 is leaving the surface. This logic is okay, right? So net outward current I will tell 0 through a junction. Clear? Net outward current I will tell 0. So why I am doing this one, you will get to know. I will do some example, then you will get to know. Clear? Let's do one example, then that will be clear for you. Let's take a simplest example. This is a resistance, let's say 2 ohm resistance, and here also another resistance, let's say it is 3 ohm resistance. Clear? And here it is connected a battery. Ideal battery basically I am taking, there is no internal resistance, or ideal cell I am taking, there is no internal resistance. Let's say here it is 10 volt battery you connect. This is positive and this is negative. So if I ask, can you find out how much current is flowing in this circuit? So can you find out how much current is flowing in this circuit? So you will tell that in 10th class you have studied, right? In 10th you have studied all these things, how to find out if resistance are series you can find out. But I want to find out by applying the Kirchhoff's junction law. So what I am doing here, I am choosing this point and I am saying that let's say this is potential is x volt. Here the potential is x volt. And this is the junction. Clear? This is the junction. And I am saying that let's say the current is flowing along this direction, I1, and current is flowing along this direction is, if this is 10 volt, this side you will tell plus 10 and this side will be 0. So x minus 10 divided by 2 ohm, right, is your current in this circuit, I1, right, plus here x minus 0, because it's 10 volt means this will be 0 volt, and x minus 0 divided by 3 ohm is your current through this is your I2. So I1 plus I2 is basically what? 0. Net current moving out of the junction is 0. Clear? This will be x minus 0. So now see here, this will be x minus 2 plus x by 3 is equal to 5. So what I can say here, this will be your 6, this will be your 5x equal to 5. So x you will get 6 volt. Clear? So though this example is looking very simple, I am just want to introduce this KCL, that's why I am doing here, right? X equal to 6 volt you got. So if x equal to 6 volt and this is plus 10 volt, obviously you tell that this I1 direction is not this direction, right? So now you will got in the answer, you will tell that I1 direction whatever you have assumed, that is not in this direction. Obviously I1 is along this direction. Clear? And how much this I1 will be? So I1 will be, this is higher potential, 10 minus 6 divided by 2, that will be your 4 by 2, that will be 2 ampere. Clear? Similarly you will say that you know that these are in series connection, right? These are in series connection. You have studied in 10th class. If these are in series connection, the current will be same here, right? The current will be same here, but I can find out I2 will be, you will say that this is 6 volt and this is 0 volt and the current will flow like this. Clear? So you can say that 6 minus 0 divided by 3 is equal to your 2 ampere. So this current direction will be along this direction. So how much 2 ampere current is flowing, right? This will be 2 ampere current is flowing. Hope you understood this one. Next, do another question. This will be this question. I know that it will be. You will tell that this question is very easy, and we don't have to do in this way. Yes, of course, you don't have to do in this way. You just series connection you do. You will get the answer easily. I just want to tell you how to apply the KCL. Let's do another example. Let's say in this question, here I am. This is your 2 ohm resistor and this is your 4 ohm resistor. This is your 1 ohm resistor, you can say, or you can say that it will be, you take it 2 ohm resistor, right? Anything you can do. And it is connected to a ideal cell and it's 10 volt. Can you find out current in each where? So let's say I am telling this is I, this is your I1, this is your I2. Can you find out? So what you will do here, you will choose a junction. You will tell that this is your junction here. This is your junction. And you imagine here is the potential is X. And you tell that if this is the X potential and this is the junction, and from that junction net outward current will be 0. Right? Net outward current will be 0. Right? So you will say that here the current is flowing I. That thing you will imagine. Because here I1, this is I2, this is your I. Clear? So this much current is flowing outward of this junction. By KCL, we are applying the KCL only. This side it is plus 10 volt, this side it is 0 volt. Clear? So you will tell that net outward current will be 0. That means I plus I1 plus I2 will be 0. Clear? So what will be I here? I will be X minus 10 divided by 2 ohm. This much current is I. If you see from the junction, plus X minus 0 divided by 4. Because here if this is 10 volt, this is 0 volt, right? This will be your I2 and I1 will be how much? X minus 0 divided by 2 is equal to 0. Net outward current is 0. So I have written I plus I1 plus I2. Clear? Okay. Now you can see here this is X by 2 plus X by 4 plus X by 2 is equal to 5. Basically 10 by 2, this will equal 5. So how much it is coming? It will be your 4. This will be 2 plus 1 plus 2. Right? So 2 plus 1 plus 2. Yes. Right? It's X equal to 5. So X equal to how much you will get? 4 volt. So X equal to 4 volt. So X you will get equal to 4 volt. Clear? Now see, if X equal to 4 volt you got and this is 10 volt, obviously the I direction will be this direction because current will flow through the resistor from higher potential to lower potential. Clear? This will be 10 volt to 4 volt. Can you tell how much the I will be? I will be your basically 10 minus 4 divided by 2. That will be 10 minus 4 will be your 6 divided by will be 3 ampere. Can you find out I1? So this is 4 volt and this is 0 volt. I1 will be, the current will flow along this direction. 4 minus 0 will give you how much? 4 minus 0 will be divided by 2. This will be 2 ampere. Clear? And this is 4 ohm. This is I2 will be how much? 4 minus 4 divided by, sorry, 4 minus 0, right? Sorry, 4 minus 0 divided by 4. This will be 1 ampere. Clear? So this is 3 ampere, this is 2 ampere, this is 1 ampere. So it is also a validate the KCL, right? So you are telling that its entering current is 3 ampere towards the junction. Leaving current is I1, you got how much? 2 ampere. I2 you got how much? 1 ampere. Entering current to the junction is 3 ampere. Leaving current through the junction will be 2 ampere plus 1 ampere is 3 ampere. So it is also validate the KCL. Right? How to solve you got to know, right? So here you take a junction and from that junction you can calculate everything. And here I have taken 0 volt. If you get confused, why I am taking here 0 volt? Because here it is 0 volt, 0 volt, 0 volt and it will be 0 volt here. Clear? This is 10 volt, 10 volt, here it will be 10 volt also. Clear? This concept I have used. This is very basic thing. Clear? This will be 10 volt, you go this direction, this will be 10 volt here. This will be 0 volt, you move along this will be 0 volt here. Because there is no resistance is sitting, right? It will be 0 volt, 0 volt, 0 volt. Clear? Let's do one more example. So this is little bit you have to calculate here. So in this example. So what in this example? Let's say this is your 10 volt battery or cell. And the resistance here it is 2 ohm and here one resistance is there, again this is 1 ohm, here is one cell is connected, that is your, let's say, 2 volt, it is connected like this, and from here there is another resistor, that is your again 2 ohm, and you can put a cell here, that is we can take this is 1 volt. Okay, see where is the junction here? You will tell that the junction is at this point. This is the junction. Okay, if this is the junction, I will take the potential of this junction is X, right? The main motive is to find out the current everywhere, right? Find out the current everywhere. If I take this is X, the potential here X, I know that net outward current through the, net outward current from the junction will be 0. Let's say here it is moving I1, here it is moving I2, here it is moving I3. Clear? Now tell me, if I apply the KCL, I will say that I1 plus I2 plus I3 is equal to 0. Net outward current through the junction will be 0. Or I can write what? I1 is X minus 10 divided by 2 ohm. Plus I2 is how much? X minus 2 divided by 1 ohm. This is X minus 2 divided by 1. Clear? Plus I3 is how much? X minus 1 volt divided by 2 ohm is equal to 0. Because you imagine this is current flowing I1, here it is I2, here it is I3. After calculation we will see whether this I1 direction is along this direction or opposite direction, whether this I2 direction is along this direction or opposite direction, or whether this I3 direction is along this direction or opposite direction. That thing we have seen, right? So here you can say that this will be X by 2 plus X by 1 plus X by 2 is equal to 10 by 2 plus 2 by 1 plus 1 by 2. This thing you will get. So it will be how much here? So this will be 2. So it will be, I can directly write. So X by 2 X plus X. This will be your 2x is equal to, this will be 5 plus 2 will be 7 plus 1 by 2, right? 7 plus 1 by 2. So if you calculate, this one will be 15 by 2. Can you tell how much x is? X equal to, you will tell that 15 divided by 4 volt. So you will get x equal to 15 divided by 4 volt. Now tell me, 10 volt is bigger or 15 by 4 volt is bigger? You will tell obviously 10 volt is bigger. So the current obviously flow in this direction. So I am changing the color here. So here it is, obviously this current is I1 is along this direction. This is the correct direction, right? After calculation you got. So can you tell me how much I1 will come? I1 is equal to 10 minus 15 by 4 divided by 2. Clear? You can calculate this one, right? Similarly, I2 will be how much? I2 will be how much? You will say this is 2 volt, this is 15 by 4. 15 by 4 volt is bigger. So the current will flow along this direction. So this is correct, right? This is direction, whatever is correct. So I2 will be along this direction. So I2 will be 15 by 4 minus 2 divided by 1. I3 will be how much? I3 will say that 15 by 4 is greater than 1 volt. So 15 by 4 minus 1 divided by 2. These are the corrects. So you can calculate. So this is your I3 direction also, same direction. So it is coming as, this will be 40 minus 15, right? This will be 25 by 8 ampere. Clear? This will be 25 by 8 will come. This is okay, right? So this will be 40 minus 15, this is 25 divided by 4 into 2, 8. Yeah. So this will be how much? So 15 minus 8, this will be 7 by 4 ampere. Right? This will be 7 by 4 ampere. This will be 8. So 15 minus 8 will be 7 and this will be 4, right? This is equal to 15 minus 4. The 15 minus 4 will be 11 by 8 ampere. Right? So I1 is current flowing towards the junction, I2 current is moving out or leaving out, I3 current also leaving out. Clear? So obviously if you add I1 plus, or I1 is incoming current is equal to I2 plus I3. You can get, right? Add I2 plus I3, this is 7 by 4, this is 11 by 8, this will be 8, so 14 plus 11, you will get 25 by 8 ampere, right? This is the KCL law it is telling, right? So first of all, whenever you will see a junction, you just imagine that there is potential is X and you apply the KCL. You will say that net outward moving current will be 0 from the junction. So X minus 10 divided by 2 plus X minus 2 divided by 1, X minus 1 divided by 2 equal to 0. And you can solve like this. Clear? Okay. This Kirchhoff's current law has another name, that is called Kirchhoff's first law, or this is called junction law. Why it is called as junction law, you got to know now, right? Because we are using the junction and we are finding out, right? This is called Kirchhoff's first law or junction law. Clear? Now we will see Kirchhoff's voltage law, that is KVL, that is called conservation of energy. So this law is basically derived from, or this law is basically associated with the conservation of energy. Why it is conservation of energy, we will go to see now. You just read what it is saying. Kirchhoff's voltage law is saying that the total sum of all potential difference in a closed loop circuit is equal to 0, right? So what it is saying, that you just see here. Let's say this is one electrical device and this side it is, let's say V1, this is plus minus, and this is another electrical device here it will be plus minus V2, and here it is another electrical device, that is your V3. I can write this is plus minus, and here it is another electrical device, that will be V4. This I can write, this is minus plus, and it is like this. Let's say Q amount of charge is flowing from here. Clear? Q amount of charge is flowing from here. It has initial energy, let's say EY, right? It has initial energy EY. So what will be energy? After crossing through this electrical device, you will say that it is moving from positive to negative. That means it is lose some amount of energy. How much energy it will lose? It will lose Q into V1 energy, right? So it will be UI minus Q V1 energy it will lose. Clear? Now here also this side it is energy will be UI minus Q V1 because it lose V1 amount of energy. Now it will flow through this charge will flow through this another electrical device whose potential difference is V2. So we will tell now it here also it will lose some amount of energy because it's going from positive to negative. So we will tell that if the Q charge is flowing here, whatever the potential energy will be here, the potential energy will be U minus Q into V1 minus Q into V2, because here also the potential energy will be loss. Here it is UI minus Q V1, here it will be U, you can write UI minus Q V1 minus Q V2. Clear? So the charge is flowing along this direction, charge is flowing along this direction, this is positive and this is negative, this is V3. Now what will happen? Again it will lose some amount of energy. How much energy it will lose? Q into V3 amount of energy it will lose. So here the energy will be U minus Q V1 minus of Q V2 minus of Q V3, right? And the charge is flowing here again, and here it will, what will happen? It is moving from negative to positive. Negative to positive means there will be increase in potential energy. How much a potential will increase? V4 into Q, right? So here if I write the potential energy, you will say that EY minus QV1 minus QV2 minus QV3 plus QV4, right? So whatever the potential energy of the charge here, the same potential energy is here because it is connected here, right? The charge is moving like this. So whatever potential energy here, the same potential energy here. So what I can write? I can say that UI is equal to, see here initially it is potential energy UI. So it is moving along this direction, it is reaching here. So it will be has the same potential energy, right? So UI equal to, I can say that UI minus of QV1 minus of QV2 minus of QV3 plus QV4. So if you say that UI get cancel out, if you see here, this will be V1 plus V2 plus V3 is equal to V4, right? Or you can say that V1 plus V2 plus V3 plus minus V4 is equal to 0. Clear? Right? So this thing it is the total sum of all potential difference in a closed loop circuit is equal to 0. Clear? So this thing I can write, this thing I proved here by conservation of energy, right? Because you take potential energy and we derived here. What I do now, you just see here, with your previous knowledge, what we can say, let's start from this point and make a loop like this. Let's the current is flowing along this direction. Clear? So you have to follow the procedure, right? So whatever I am telling, you have to follow the procedure. Here the current is flowing like this, let's say. If the current is flowing like this, you will say that here it is going from plus to minus, right? Here it is going from plus to minus, and you know that whenever you are moving, there will be a drop in potential, right? There will be a drop in potential. Here I can write minus of V1. Clear? This is loop I am taking. This is loop. That's why it is also, the another name is also loop law. This loop I have taken, right? This clockwise loop I have taken. So here I am starting. Just here we will do some problem, it will be clear, but try to understand here what it's saying. Let's say I am starting from here, I am moving. Here it will be a loss in potential, right? Because you are moving from positive to negative. So you will write minus V1. Here you come, here again positive to negative, you will write minus of V2. Here you will come, here again there will be loss because you are positive to negative, minus of V3. But here it is negative to positive, that means there will be rise in potential. So you will write plus V4 is equal to 0. So it is coming as V1 plus V2 plus V3 equal to V4. The same thing, right? We will do some problem, this will be easy for you, you can get to know, right? So what you have to do, you have to choose a loop here. This is a loop. I am starting from here and reaching to here with this direction. And in this direction, if I am saying, if I am moving from positive to negative, there is a drop from potential. If I am moving positive to negative, there is a drop in potential minus V2. Here is drop in potential minus V3, but here is a increase in potential V4 because it's negative to positive. And this thing, it is proved by this conservation energy, right? This is right, okay. So this is called a loop law, or this is also called as Kirchhoff's second law. This is also called as Kirchhoff's second law. Clear? Okay. Now see some problems here. Hope you understand. So using this concept, we will do these problems here, right? The magnitude and direction of current in the following circuit is. So they are asking the magnitude and direction of the current in the circuit. Okay. We will apply KVL or loop law to find out. Just see the problem. Let the current is flowing along this direction. I current is flowing along this direction. I am assuming let the current is flowing along this direction. I am not saying that this current is flowing along this direction. I am assuming. Okay. If it is assuming, I am assuming current is flowing along this direction. What I will do? My first work is to do a loop here along this direction. I will do a loop. The same thing I am doing here. The loop I am making here. You also make a loop like this. Clear? This is point A. Let's say I am starting from here. Similarly, I am starting from here, you remember in this case. Here I am starting from this point. Now you have to tell me what will happen. Along the direction of the current, if you are moving through the resistor, there is what will happen? There is a drop in potential. How much drop in potential? That will be minus 2 into I, that is IR. Clear? Here is the cell. You are going from negative to positive. You are going from negative to positive. If you are going from negative to positive, there will be an increase in potential. How much increase? This will be plus 10. Clear? Okay. Now here, if you see, I am moving along this direction. Here it is higher to lower in 5 volt EMF, right? So with this higher to lower, you can say that here the potential will be drop. I will write minus 5. Step by step I am doing. Now in this direction the current is flowing, I imagine. So along the direction of current through the resistor, it will be how much? Minus 1 into I. I will write I. 1 multiplied I will be I. I will move here. If I move here, along the direction of the current through the resistor, there will be a drop in potential, that will 7 into I. And you know that sum of all the potential difference is equal to 0. I hope this is clear. I choose this point, assume the current is flowing along this direction, and write down all that thing whatever we have studied in previous class. Clear? I write down all the things whatever we studied in the previous class. This is the case. Now we have to solve here. This will be 10 minus 5. This will be 5 is equal to minus 2i minus I minus 7i. This side it will be 10i. So I will be 5 by 10, that is equal to 0, 1 by 2. You can say 0.5, right? So you can write this is 0.5 ampere. The current is coming as positive here. See, the current is coming as positive. If the current will coming as positive, that means whatever direction you have assumed, that is correct. Clear? Whatever direction you have assumed, that is correct. Okay, so you can say that the current will be 0.5 ampere along this direction. Now check the option. First option, 0.5 ampere from A to B through E. 0.5 ampere, this is true. From A to B through E, yes, that is correct. So option number 1 is correct. You may have doubt, right? What will happen if I take the direction of the current will be opposite? So let's take the direction of the current is opposite. So let's do that problem. What? This is point A. This one we can take. This is will be point A, and here this is 2 ohm, and this is your 10 volt. Here it is 5 volt. 1 ohm resistor, this, and here it is 7 ohm resistor. Clear? Okay. Now I imagine the current is opposite direction. Here we have taken along this direction. Let's take the current is along this direction. I is along this direction. The I is flowing along this direction. Clear? Now choose a point as a starting point. Let's say I choose this again A point as a starting point, and the loop I am taking like this. This time anti-clockwise, because the current is flowing along this direction. I will take anti-clockwise. Clear? Now tell me, the current I am starting from point A, moving along this direction, because the loop is anti-clockwise direction I have taken. The arrow I have put. See, this is A. Move through the 7 ohm resistor. Whenever I will move through the 7 ohm resistor in the direction of the current, there will be a potential drop, that will be minus 7i. Clear? Then you reach here, again same for the 1 ohm, you will say that minus 1i. This direction if I come, I am moving from lower potential to higher potential. That means there is an increase in potential. So I have to write this is plus 5 volt. Clear? This is I have to write plus 5 volt, because I am moving from lower to higher, lower potential to higher potential. Plus. This is from positive to negative, that means there will be a potential drop. How much? Minus 10. In this direction, you are moving along this direction, in this loop you are moving, and the current direction also same. So there will be a drop in potential, that will be minus 2i, and all potential drop you will write 0. Add all the potential drop, this will be 0. Now add all these things. So we will get minus 5, minus 7i, minus 1i, minus 2i, minus 10i. So if you solve here, I is coming as minus 0.5 ampere. So current cannot be negative. The current cannot be negative. If the current is coming negative, that means you have choose the direction wrongly. Only you have to do here, make this current positive and reverse the direction. So originally in answer, the current direction should be along this direction, because current cannot be negative. So this is the direction of motion of the current, right? So you can say in this direction the current will flow. You have assumed that direction of current is along this direction and you got minus sign. As soon as you will get minus sign, you will say that okay, I have assumed this direction, so this direction is not correct, so it will be opposite direction whatever I have choose. The answer will be in the opposite direction whatever I have choose, and magnitude will be the correct answer here. So magnitude will be 0.5. So 0.5 ampere current is flowing along this direction. Clear? I hope this is clear. Okay. Now see this question. For the circuit shown in the figure, the current I will be. So here they have given the direction. They have already given the direction, right? They have already given the direction. You have to find out the magnitude of the current, right? Or direction already given means you have to find out the magnitude of. So if the direction is along this direction, they have given already, this is the direction of current. What I will do, I will choose a loop like this. Clear? I will choose a loop like this. That means I am moving from here and reaching to this point, and it will be anti-clockwise direction. And start, let's say start from this point. Any point you can start. I am starting from this point. You are moving along the direction of the current through the resistor. There will be a drop in potential. You will write minus 4 into I. Plus, you are moving along the direction of the current through the resistor, there will be a drop in potential, minus 1 into I. From negative to positive you are going, that means there is an increase in potential, that is plus 4. Plus, along the direction of the current through this resistor, this is 1 into I. Plus, from negative to positive, that means there is a rise in potential, this will be plus 2 is equal to 0. So what I can write, this is 4I, this is minus I, minus 4I, this is minus I, this is plus I, right? This should be minus, na? Again this should be minus, because you are moving along the direction of the current, right? If the along the direction of current, this will be negative, right? So how much it will be coming? Minus 4I, minus 1, minus 1. So it will be minus of 6I plus 6 is equal to 0. So I will be how much? 1 ampere. So current will be 1 ampere. So you will see here that current will be, option number 2 will be your correct option. Option number 2 will be your correct option. Clear? I think this is clear for you now. For the circuit given below, the Kirchhoff's loop rule for the loop BCDEB is given by the equation. This is BCDE. Let's take the loop I am taking like this, right? Now you have to tell me, if I2 current is flowing, here I am starting, this point I am starting. If you are moving along the direction of the current through the resistor, for this loop I am writing a BCDEB. For this loop I am writing. Starting from here, there will be a drop in potential, minus I2 R2. Why there is a drop? Because the direction of current is same as direction of my, because I am moving along this direction, right? The direction of, so what I can say, the direction of the current is same as the direction I am moving, or the loop I am taking in the same direction. So there will be a drop in potential, that will be I2 R2. Clear? If this is I2 R2 and here it is positive to negative, that means there is a drop in potential. Here it is negative to positive, that means there is a rise in potential. Now see here, you are moving along this direction, the loop is along this direction, but the current in opposite direction, right? So you have to write here plus R1 I3 is equal to 0. So what you will got here? You got that E3 minus E2 minus I2 R2 plus I3 R1 is equal to 0. Right? Just see which option it is matching. Minus I2 R2 is there. Minus I2 R2 here, it first option and fourth option we have to check. Minus I2 R2 plus E2, not in plus E2, right? So it is now I3 I2 R2 and I3 R1. Okay, so you have to check here. So this will be your E3 minus E2. You just check here E3 minus E2. I think they have changed the sign. So what we can do here we can do that, we can write this one is minus of E3 plus of E2, or they have written the current, this I2 they have written first, we will write in that format. They have written I2 first. So I2, if I write, I just multiply a negative sign here, this will be I2 R2, right, I2 R2, and then they have written E2, this will be plus E2, right, this will be minus E3, and this will be minus of I3 R1 is equal to 0. Okay, minus of I3 R1. You just check here which option it is matching, I2 R2 plus E2 minus E3 minus I1 R1. So this option will be correct. Option number 2 will be correct here. Okay. Now in next class we are going to see this thing. So option number 2 will be correct. So next class we are going to see this thing, right?